The next thing we're going to want to know as we're adding our titrant is what's the equivalence point. So of course, since this is a one-to-one stoichiometry, it's just going to be when our moles are equal. So we can take our moles of hydroxide is just going to be the volume, 50 milliliters, times the concentration, 0.02 millimoles per milliliter. And this, when we multiply this out, we'll get that this is equal to 1 millimole. And now we need to figure out what volume of H plus of the HCl solution is going to be required to match that. So we can take our moles of H plus, it's going to be equal to 1 millimole. And then we want to multiply that by our concentration. Well, divide it by our concentration, 0.1 millimoles per milliliter, and that'll give us that our equivalence point will be at 10 milliliters. Okay, so now we can look at some points along the titration curve. Similar to the precipitation titration, we can look at points before the equivalence point, at the equivalence point, and after the equivalence point. So let's look at doing one before the equivalence point. So let's say we've added half, 5 milliliters. 5 milliliters of titrant added. And what we're looking for is what is the pH of this solution. Now, there are a few different approaches we can take here. Mostly what we need to know is, what's going to happen is all of our H plus is going to react with our hydroxide and produce water. And then we'll have leftover hydroxide that will control the pH. So again, similar to what we see in precipitation titration, it's just that the equilibria involved are slightly different. All right, so we know we have 1 millimole of hydroxide. We just calculated that by free calculating the equivalence point. And at 5 milliliters times 0.1 molar, we have 0.5 millimoles of H plus, which means that our leftover OH will be equal to 1 millimole minus 0.5 millimoles, which means we will have 0.5 millimoles of hydroxide left. And now we need to find the concentration here. So the concentration of hydroxide will be equal to 0.5 millimoles divided by 55 milliliters. So we have our initial volume plus our 5 milliliters of titrant that we've added. And that'll give us a concentration of 0.00909 molar. All right, and then we can go ahead and use the Kw expression to find the pH. And we're going to skip those steps, but our pH is 11.96. Now, if we go back and look at our initial pH was also pretty high. We had a pH of 12.3. There we go. Computer's just taking some time to get up there. And so we see the pH didn't change very much because we haven't neutralized all of the base yet. That's really the reason. We have a bunch of strong base left in the solution. So this is what we're going to see in this area before the equivalence point on the titration curve is the pH is not going to change a whole lot until we get very close to the equivalence point. All right, so in the next video, we'll look at what happens at the equivalence point.